here is the second example from this part. So now we want to evaluate this line integral that is given in the differential form over a curve C. Your curve C is the circle with the equation x squared plus y squared equals 9. Okay, now let's use the Green's theorem. So we have a closed curve, so we could apply the Green's theorem to evaluate this line integral. Now the part that associated to dx is your p, and the part that associated to dy is your q. So now Green's theorem says this line integral equals to double integral over domain D of partial q over partial x minus partial p over partial y dA. So let's figure out these two partial derivatives. Partial q over partial x, so derivative of this second component with respect to the x variable is 7 minus derivative of this one with respect to the y variable is 3 dA. So this is nothing but 4 dA over the domain D. Now what is your domain D? Your domain D is on the xy plane, and it is a circle with radius 3. So this is x squared plus y squared equals to 9. Okay, so since we have a circular domain, it is easy to use the polar coordinates to solve this integral. Okay, so we have 4 times r dr d theta. Okay, and r goes from 0 to 3, and theta goes from 0 to 2 pi. Now I hope you all could solve this, but here is a shortcut way to solve this specific double integral. Now think about this double integral. So here we have, if you factor out 4, then basically you have 4 times double integral of 1 dA over the domain D. The domain D is this. So geometrically, this double integral means the area of the circle. Okay, now area of the circle. Now we have a circle with radius 3. So what should be the area of that circle? It should be 4 times. Let's say it should be 4 times pi times r squared is 3 squared. So you should get 4 times pi times 9. If you multiply these 3 quantities, you should get 36 pi. Well, this is the value of the line integral over the closed curve C.